Hello, fourth period. These are your notes for 8.1 and 8.2 in our workbook. So you'll need to have the copy of the notes out in front of you. And now we're going to take a look at how we can use factoring to actually solve quadratic equations. So factoring is one of the methods that we can use to solve a quadratic equation. The first thing we need to understand is how the zero product property works. If A times B is equal to 0, then we know that either A must be 0 or B must be equal to 0. One of the two of those values must be 0 in order for their product to also be equal to 0. This requires the equation to be set equal to 0. It also requires that the equation is fully factored. Got to be careful with our GCFs and our negatives. So these three steps are really important, and they're what you guys need to think about as you do the problems in 8.1 and 8.2. The first step is to make sure that you set your equation equal to 0. In the beginning stages, when you do your first few problems and you get them wrong, be sure that you had got your equation equal to 0 before you factored or tried to solve. You also need to make sure that you factor completely. And lastly, you need to be able to solve your equation for x. So this first example, if you notice, I titled it 8.0. This is because it's not very applicable to your 8.1 or your 8.2 homework, but it's how you handle a situation that's not a trinomial. In this case, this just involves a GCF. So when I look at this, notice first that I have the equal sign. This is a quadratic equation. It's set equal to 0. So that's my step one. It's already done for me. So now I have to factor completely. Looking at these two terms, I notice they both have a 2x in common. So let's pull that out. I get 2x plus 1 remaining. This is my situation. This is my A times B that we talked about above. If I could slide this back, this is my product of two terms. It's equal to 0. So I know that either 2x must be equal to 0 or that 2x plus 1 must be equal to 0. This or is not a significant or. I could have not wrote it, and my problem would have been just fine. So in this case, I can divide both sides by 2, and I get x equals 0, or, and again, you could write an or not write an or. It's not significant. Over here, when I subtract 1 from both sides, I get 2x equals negative 1, or x equals negative 1/2. These are my two answers for x. X can be 0 or x can be negative 1/2. I'm going to get two solutions because this had an x squared term. And if you look at the graph that I've included for you, notice that these solutions, if this is 0 and this is negative 1, this is my x equals negative 1/2. This is my x equals 0. The solutions to a quadratic equation are also the x-intercepts. So down at the bottom, this sentence is supposed to help us understand the vocabulary that we're going to be able to use. So if it asks for x-intercepts, I need to solve the equation. In this case, it's x equals 0 and x equals negative 1/2. If our problem asks for the zeros of the function, remember that's where y equals 0. Then they're also asking for the x-intercepts. And again, my solution would be x equals 0 or x equals negative 1/2. And then finally, if we're asked for the solutions of the given equation, again, we're looking for those x-intercepts. So x equals 0 and x equals negative 1/2. That would be the answer to the question solving. Let's take a look at another problem. This is a problem like you'll encounter when you're doing your 8.1 homework. This is a problem where your trinomial has an a equal to 1. So The first thing you'll notice is that our step 1 from above is not done. This is not set equal to 0. I like to keep my x squared terms positive, so I'm going to subtract my 9x to move it to the other side, and I'm going to get an x squared minus 9x plus 18 equal to 0. There's no like terms to combine, an x squared term, an x term, and a constant, and so it's time to factor this. So one method for factoring this is using our x, where at the top we write our AC, which in this case is 1 times 18, or positive 18. In the bottom we put our b, which is negative 9. And then we think of two numbers that multiply to 18 while adding to negative 9. Hopefully you thought of negative 6 and negative 3. Because there is no a term here, I'm allowed to just write my factored terms as x minus 6, x minus 3, and again, that's because that my a is 1. Notice, unlike what we were doing before, there's an equal to 0 here. This is my situation. This is my a times b equals 0. So I know that either the term x minus 6 equals 0 or the term x minus 3 is equal to 0. And now my step 3, I solve these. So x equals 6 or x equals 3. Those are my solutions to my given equation. Notice I have the graph of x squared minus 9x plus 18 over here. And notice on that graph that it goes through the x-axis at x equals 3 and x equals 6. So we know a lot of information about our graph now. We know our x-intercepts are x equals 3 and x equals 6. We know the zeros of our function. Remember, that's the values of x that make my y value 0. And that occurs at x equals 3 and x equals 6. And if the problem had asked for the solutions to the equation, we know that the solutions are x equals 3 and x equals 6. If you wanted to check this answer, you could substitute them back into the original equation, and you should find that it makes it 0. We have another problem on the next page that is similar to the last one we just did. So notice our step 1 is not done. I do not have this equal to 0. I'm going to add 12 to both sides, and when I do so, I get x squared minus 8x plus 12 is equal to 0. This now allows me to factor completely my step 2. My AC is 12, and my b is negative 8. So now I'm looking for two numbers that add to 12, that multiply to 12 by adding to negative 8. Hopefully you're thinking about negative 6 and negative 2. Since my a is 1, I can just write x minus 6, x minus 2 in parentheses. And now I can solve. This is my situation where my a times b is equal to 0. So I know that either the x minus 6 equals 0 or the x minus 2 is equal to 0. So x equals 6 or x equals 2. Again, I've included a graph of this function. This is the graph of x squared minus 8x plus 12. And notice that the x-intercepts occur at x equals 2 and x equals 6. So let's take a moment and fill in that our x-intercepts are at 6 and 2. Those are also the zeros of my function. And lastly, they are the solutions to this quadratic equation. These problems will help you do the problems in 8.1. Let's take a look at the example 3. It says we have a rectangular porch that has the dimensions x plus 12 and x plus 5. It goes on to say that the area of this porch is 120 square feet. It wants to know what the length and the width are. So we know that the area is equal to the length times the width. So let's take our area, which is 120, and set it equal to the length, x plus 12, times the width, x plus 5. So in this problem, we don't have our step 1 from the previous page. If you look back on the front page, our step 1 is to set it equal to 0, and then to factor completely. So since I have this 120 on my left side, my equation is not set equal to 0. With my two binomials here, there's no like terms to combine the 120 with. So before I can do anything else, I actually need to box or FOIL my two binomials so I can write the right side of my equation as x squared 17x plus 60. So now my equation is ready for me to set it equal to 0 by subtracting 120 from both sides. When I get this, I have my x squared plus 17x minus 60. So now I'm ready for step 2. I can factor this completely. So I look at my a times c on top and my b on the bottom, and I try to think of numbers that would multiply to negative 60 while adding to a positive 17. Hopefully you were thinking about using 20 and 3. So this gives me x plus 20 and x minus 3. And I can set each equal to 0. And I get that x is negative 20 or that x equals 3. So we need to pause here and take a look at our two answers. Negative 20 and 3 are the solutions to this equation. They are the x-intercepts of that parabola. They are the solutions to the equation. They are the zeros of the function. However, since this is a real-life problem about the dimensions of a porch, if I plug the negative 20 into my original problem, I would get that my length and width of my porch are negative numbers. You can't have negative distance, nor can you have negative time, which we'll also deal with in the future. So I literally cross out the x equals negative 20 because for this particular problem about porch dimensions, it's not applicable. So I use x equals 3, and to find my porch dimensions, I simply substitute it in. So into the x plus 12 would give me 15 feet, and into the x plus 5 would give me 8 feet. So my porch dimensions are 8 by 15. This problem ends the problems I'm going to do for section 8.1 at this time, and we're going to begin 8.2. So if you would turn to the next page, you would see the new title, 8.2, factoring with an a greater than 1. So as you remember, when I have a greater than 1, I have to use a different technique to factor it. So these problems are slightly different in the method that I use to solve them than the ones we just looked at. However, the first three things that we talked about are still the same. I'm still going to set it equal to 0. I'm still going to factor completely. And finally, I am going to still solve. So in this particular problem, I don't have it set equal to 0. So now that I have added the 4 to both sides, I have set my quadratic equation equal to 0. And now I can do step 2. I can factor it completely. So in this problem, as you look at the three terms, I find that they all have a 2 in common. This is my GCF. Don't forget your GCFs that we learned before. When I factor out a 2, I get x squared plus 3x plus 2 equals 0. So I now realize that this problem is not an a greater than 1. This is a problem where my a is equal to 1, and I had a GCF of 2. So what do we do with that GCF? We just let it hang out in front, and then we factor our trinomial. Our new a times c is 2, our b is 3, and then we think of our two numbers on the side, and they would be 2 and 1. So when I factor this, completely factored, this problem would be 2 times x plus 2 times x minus 1. However, setting the 2 equals to 0 makes no sense. So the 2, the GCF, just kind of hangs out in front, and it's not any part of the problem where I set the x plus 2 factor equal to 0 and the x plus 1 factor equal to 0. Since this has no variable, the 2 is just a GCF in the front and I don't worry about it. So I get x equals -2 and x equals -1. And if you look at your graph, I have at x equals -1 and at x equals -2, I have an x-intercept. We also call that a 0, and we also call that a solution to my equation. So I can write that in for all 3 of these here. So what happens when I can't factor out my a, when I don't have a GCF where I can do that? Let's take a look at this problem. I like to keep my squared term positive, so I'm going to subtract the 2x squared. I'm going to subtract the 7x, and finally I'm going to add the 2. And again, this is so I can get it set equal to 0, but it also keeps my x squared term positive. So I get 2x squared. There's nothing to combine the 7x with, so I get minus 7x plus 6. You'll notice that this does not have a GCF. So when I do my a times c, I get a 12 on the top and a -7 on the bottom. Again, I'm trying to see what I can multiply to get 12 and what I can add to get 7. -7. So I'm hoping you were thinking -3 and a -4. Remember, we cannot put these into our binomials because we have an a. So this is where I now factor by grouping. I keep my 2x squared, I keep my plus 6, and now I write in a -3x and a -4x. And this is where I factor by grouping. You'll notice here that I get an x as my greatest common factor, so I have 2x minus 3. Be careful with your signs so that I can get a positive 2x and a -3. I'm going to factor out a -2, which would then give me my 2x minus my 3. And finally, to finish this off, I'm going to factor out my 2x minus 3, and I'm going to then have an x minus 2 left over. However, you're not done, because unlike the last unit when we just were factoring, I'm solving here. This is my a times b, which equals 0. So I'm going to set my 2x minus 3 equal to 0 and my x minus 2 equal to 0. This is going to give me 2x equal to 3. It's going to give me x equal to 3/2. I'm also going to add 2 to both sides and get x equal to 2. And if you notice on the attached graph, which is the graph of 2x squared minus 7x plus 6, you'll notice that I have an x-intercept at 3/2, which is also 1.5, and you'll notice I have an x-intercept at 2. So those are my two x-intercepts, 3/2 and 2. My zeros are also at x equals 3/2 and 2, and my solutions were in x equals 3/2 and x equals 2. It would be fine to write that as 1.5 as well. Our last example for 8.2 today. So this problem is not set equal to 0. That is my mistake. So if you could write equal to 0, I'd appreciate that. So please write equal to and then 0. So this problem has a GCF. If you notice, all of these are multiples of 3. It also has a leading term, x squared term, that's negative. If you'll remember in the last unit, I recommended factoring out the negative so that your x squared term was positive. It's not necessary to factor, but it does make factoring easier. So let's factor out a -3. This will make my x squared term positive, but it changes the sign in my next two terms. So I get a minus 7x minus 6 equal to 0. So if you remember, this is a place where you might like using brackets to enclose your factoring work. So at the top of my x will be 5 times -6 or -30. At the bottom is -7. So I'm looking for two numbers that add to -7 while multiplying to -30. So I need a positive and a negative number, and I hope you're considering -10 and a +3. So this is where I now have to use factor by grouping. I keep my 5x squared, I keep my -6, and in place of the -7x, I'm going to write -10x and positive 3x. And this is where I begin my factor by grouping. So I get negative 3 times, in this first term, they have a 5x in common. That will leave me with an x minus 2. In the second term, they have a 3 in common. That will leave me also with an x minus 2. Perfect. So finally, my GCF gets to stay out in front. I'm going to factor in x minus 2 out of both terms. That leaves me with a 5x plus 3 left over. And then this would be step 2. This is now my equation fully factored. So again, like before, there's no x with this negative 3. I'm not going to set negative 3 equal to 0 because that's not a true statement. Since it has no variable with it, it's just a coefficient that I don't worry about at this time. I set my x minus 2 equal to 0, and I set my 5x plus 3 equal to 0. And then I solve. And I get x equals 2, or here I get 5x equals negative 3, so x equals negative 3/5. These would be my two x-intercepts, 2 and negative 3/5. These would be my zeros in my function, 2 and negative 3/5. And this is the solution to this quadratic equation. It's when x equals 2 and x equals negative 3/5. I appreciate you listening carefully and taking your notes. If I went too fast or there is something you did not get, this video will also be in our locker. And at this time, you can work on your homework for 8.1 and 8.2 in our workbooks. Thank you.